Alright, so welcome back. What we're going to do today is we're going to go back to our basic Python and talk about functions. So what is a function? Well, a function is a reusable block of code that performs a specific task. Some of those use cases are you avoid code repetition. So if you're writing code and then you're find out that you're writing the same thing over and over again, you might want to write that into a function. It also allows you to organize your code logically and enhance readability and maintainability. So usually after you do your import statements, you can put your functions at the very top of your code, and that way if you make a mistake in one of your processes in a function, you can just change it there and it will populate the rest of your code, and you only have to change it in one place. Plus, it's easier to read because it's right there laid out, and maintainability is going to be a breeze going forward. Then I'm going to show you the return values for farther computation. So basically, when you call a function, you can return a value, and you can take that value, and as long as you put that in a new variable, you can use that and farther on the calculations like in your code later on. If that sounds good, we're going to get started with the agenda. So the types of functions that we're going to go over, we're going to do the built-in functions, which these are simple. They're like your print command, your length, your max, your sum. These are functions that are already embedded into Python. Then we're going to move on to the user-defined functions, which these are the functions that you define yourself, and they're recognized by, you'll have DEF in front of that, and then you'll have your function name and the parameters, and then what you're going to do your calculations, and you're going to return that. Then you're going to have anonymous functions, which are your Lambda functions. And just wanted to kind of give you a high-level review what type of functions there are. In this exercise, we are going to specifically talk about the defined functions. Okay? So we're going to go over the function parameters, and we're going to do positional arguments, which basically when you pass in variables, they have to be in the same order as you're declaring in your functions. And this will make sense a little bit later on. Then we'll have keywords arguments where we specifically declare what parameters we are passing, and they can be in any order because we're using the keyword arguments. Then we'll talk about the default arguments, and if you don't put any arguments in, we can tell Python these are the default arguments. That way if somebody calls our functions and they don't pass anything, we can have default arguments where our function won't error out. And then we'll go talk about the variable length arguments, which is usually when you see Args and Kwargs. And basically, an arg is for multiple positions, where a Kwarg is for multiple keyword arguments, so you can think of more of a data dictionary. Then we're going to talk about these return values. And we can return a single value, we can return a list, we can really return anything with single values in it. And we can do multiple values. So for example, instead of just bringing back one number, like a equals 1 for example, let's say I want to bring back two values where a equals 1 and b equals 5, I can actually bring back both values independently using multiple values. Then we're going to talk about the scope and lifetime of variables. So basically, what you have inside your functions is you have local variables. And these are defined inside the function itself, and it's only accessible in the function. It's not accessible once you leave that function unless you put it in another variable. Then you have global variables, and they can be used anywhere inside or outside a function. I don't like using global variables for multiple reasons, but if you want to use them, be my guest. Then we're going to talk about higher order functions, okay? And these are functions that take other functions and arguments or return functions. So basically, if I have a function and and every time I call one function, I want to call another function, or even call another one, I can do that by writing it as a higher order function. Then we're going to discuss the closures and nested functions. And basically, a closure is a nested function that removes values from the enclosing scope. And that'll probably make more sense when you see an example of it. Then, we're going to do the classic exercise using recursion. And basically with, recursion, it's just a function that calls itself. We'll probably use the example of a factorial on that. And then we're going to go over decorators. And basically, what a decorator is it's a function that modifies other function behaviors. And we'll show an example of calling a decorator and having it write something before and after a function. And the last thing we're going to cover is docstrings and type hints. And docstrings basically describes the function, so it kind of helps people out if they don't know what it's doing. They can call the docstring and figure that out. And then the type hints just the respective types for better readability and tooling support. And if all that sounds good, let's get started. Okay, so we're going to go over the types of functions. So right up here, Python provides many built-in functions like print, len, max, sum, etc. So I have my numbers here already in a list, and I can print the length of those numbers, and I can run that, and I'll get 5, because if we count those, that's 1, 2, 3, 4, 5, right? I can do the max and get the max number, which is 10. And I can do the same thing for minimum. I could print this out. I could sum this and get 20 out of that. That's pretty much it for the built-in functions. They're pretty straightforward. And, we've been using those all the time without thinking about them. So there's not really much to say about them. So the next thing we got is the user-defined functions. Okay, so these are the main functions that we declare ourselves. And we do that by defining it. We'll have def, and then we'll name our function. This one's going to be squared, because our example is we're going to take the square of a number, i.e. the exponent or power, and squared is the name for the power of 2. So we're going to take a square, and we're going to say x, right? And then if I put that in there, I can do return x, and remember from previous classes we have the power 2. So if you need a brush up, if you look at the learning series, I do have a math version up there that goes over the numbers and stuff that you can take a look at. So we have return the power of 2. Okay, so to get that, what I'm going to have to do is I'm going to have to print, and I'm going to call square. So I'm going to call this square because I'm defining that as the function. And then it's looking for me to pass x. So I'm going to pass, let's say, 5. So that's going to return 5 to the power of 2, which should be 25. So I got that. So building a simple function is simple as that. Now there's more things we can do with this function that I'm going to go over at the end of the video. I'm just trying to keep it simple now and then build on those blocks. So if I go down here to the anonymous functions, which is like the Lambda function, we can do the same thing, right? And this is going to do the x, to the power of 2, right? Or squared. So I can do square just to keep, I'm not putting a D on this like I did up here, just to keep it different to show you, okay? So this is going to be square, and this is going to be equals lambda, okay? So now I'm going to have x, and then x is going to be the power 2, right? So I'm going to take the x, and then it's going to be x power 2. Okay, so x is what I'm passing in, and then it's going to be the power of 2. Okay, And then all I got to do from here is print square. And then again, I'm passing in x. So I'm going to pass in 5 again and get 25. So dealing with an anonymous function is really as simple as that. Okay, so now I'm going to go over functional parameters. I'm going to talk about positional arguments, where we simply add two numbers together. So I can define my function by doing def to define my function. Then I'm going to want to add, and you want to name your function something that's rememberable and something that's short and concise. Just, if you know what it is, and then, it's just easier instead of like naming it something like long or something you don't remember in the future. So you want to keep it something that's relevant. Okay, so I'll do A and B. And then I put my colons, and then what I'm going to do is I'm going to return A plus B. Okay, and I don't need my parentheses there. So I'm going to return A plus B. Okay, so now if I print, and then I'm going to call my function add, and then I'm passing in, let's say, 2 and a 3. Okay, if I run that, it's going to bring back 5. Okay, and I know these are simple, but usually functions are going to be a little bit more complex, a little bit more logic in, but again, we're just trying to keep this simple. Now we want to do keyword arguments. So if I want to use this function, I want to use it again, for example, but let's say that I want to mix my numbering up. Okay, I can say print, and we have add, and then we have 2, 3, and this time I want B to equal 2, but I want A to equal 3. And if I run it, it's still going to give me 5. Okay, so that's both 5, but these are different orders, right? So they will give me different values. For example, if I change this A minus B, for example, what order would really matter? This is actually a subtraction now, and I run this, and I get a -1 and I get a 1. That's because A minus B, that's 2 minus 3, that is a -1. But if I come down here, A is now 3, and then 2 is now B, right? So A would be 3 minus B would be 2, and I'll get a 1. So we could either pass in the keyword arguments, or we can just rely on the order that we define it in our function. So it depends if you want to be more explicit or if you just want to kind of like list them out. Either way is fine. It's really a preference. So let's go down to default arguments, for example. Okay, so for the default argument, sometimes people won't put in an argument and your function's going to fail. Okay, and we don't always want that. So, for example, we have our definition, and then we have like a function called greet, and we'll have name. Okay, and then we're going to return an F string, and we're going to say, actually we're just going to say name in here. Okay, and let me spell return correctly, would probably be nice. There we go. Okay, pretty simple, pretty straightforward. Okay, so now if I print greet, right, and I put in here hello world, right, for example, it's going to say hello world. But let's say that I forgot to put anything in here and I run this, it's going to error out because I'm missing one required position argument. Okay, and I don't want that. Okay, I always want this to work. So I could do like something like this, name equals like and subscribe. So now what's going to happen is I don't have an argument here, but my default's going to be like and subscribe. So if I run this, I can do like and subscribe because that's my default value. Okay? So let's say that I wanted to say something else and I know what I want to say, but I'm going to pass the parameter. I can say hit that bell. And I can run this, and now it's going to say hit the bell because I did declare the name in here. So it's going to override the default argument. And it's really as simple as that. Okay, the next thing I'm going to do is I'm going to look at the variable length arguments. And how do we add numbers using args for multiple positions, right? So let's say that I have a function and I want to sum all of my numbers up, for example. But I don't know how many numbers I want sum. I can do star args, okay? And then what I can end up doing is I can return, okay, the sum of args. So now, if I say print sum all, I can pass in 1, 2, 3, 55, 64, 105. It doesn't matter how many numbers I pass in here. It's going to add them all up. Okay? So even if I only pass one number, it will add that up. Or if I only pass 3 numbers, it will add those up. So it's pretty simple. Now, what makes this as args is that star right there. So if I sit there and change this to whatever, for example, whatever, and I change this to whatever, because those have to match because that's what I'm passing, I can run this and it will work. So what makes this as an arg is that star, like right there. Okay? So to just give you an example that you can name that whatever you want it to be named and it will work. The key thing is the star. The second thing that we're going to do is for the Kwargs, right? So let's say that I want to print some info out. I can do the function. I can do print info, and usually they like the underscore in there. It's I believe they call it snake case on there. But anyway, you want to use the underscore on there. And then if I do the print info, I can do star star and then KWARG for my Kwargs. Put a little colon up there. And then remember, these are more dictionaries, so it's going to be for key value in Kwargs dot items. Kwargs dot items. We're going to print the function, and we have the key, and then we're going to have the value. Okay? And if you need more information on what it's doing here, is you can look at my class and dictionaries. Okay? So that's pretty much it for that. Now I can run this, let's say doing my print info, and I'm going to say name, and we're going to go with Harry Potter. Okay, we'll go with Harry Potter. And then in the books, I think he was born in 1980, so that would make him 45. Okay, so if I run this, Kwargs is not defined. Oh, because I misspelled it. Kwargs. Okay. If I run it, now I have name, Harry Potter, and I got age 45. So it's actually pretty simple. And again, same thing with Kwargs. I can say, my new stuff, and I can name this new stuff. I want to name it new stuff. I'm just showing this as an example, just to show you what makes this a Kwargs as these 2 stars. And if I run that, I get the same results. Okay? Okay, so we're going to talk about returning values. And we've been doing this throughout already, so this is nothing that's going to be groundbreaking. So basically, if we have a function and we have get numbers, for example, and I want to return let's say I want to return a list of 1, 2, 3. Okay, pretty straightforward. It could be a string if I want to. I'm just returning numbers. Okay, and then I want to say numbers equals, and then get numbers. Okay, and what this is going to do is that I'll be able to use these numbers again because I'm taking get numbers. I gotta put my parentheses there. I have my get numbers. I'm calling my get numbers, and it's going to return 1, 2, 3, and I'm going to store them in numbers. So now what I can do, I can print numbers out, and I can actually use those values elsewhere in my code. So that's my numbers right there. So now if I do like, like for x in numbers, I could print x, and then I'll print those out 1, 2, and 3. So that's basically it. It just lets me return the numbers there. I'm storing them in a variable, and then I'm calling them outside the functions because I store them in a variable outside the function. Okay? And I'll show an example of global and local variables a little bit later. So we also can return multiple values. Okay? So let's say we have DEF for our functions, and we have 2 example, and I'm going to do A and B. Okay? And then from A and B, I'm going to return A plus B, right? No, I'm going to return A and comma B because I said I'm going to return 2 examples. Okay? So now what I can do is I can do like HW equals, and I can do 2. Actually, I'll do this. I'll do an L, and I'll do an S. And I can do 2 example. Okay? And you're like, why would he do L and S? Well, you know me. I'm going to do like, right, as 1, and I'm going to do subscribe as the other. Okay? So if I run that, that would just have my functions right there, and it will put L and S, as L will be like, and then S will be subscribe. And maybe I'll just capitalize my scribe just to make it consistent. Okay? So how would I use this? So I could do print L, and if I run that, that's only going to show like. Okay? So if I do S, it's going to do just subscribe. So I actually broken those up in multiple values, right? So I could do print, and I can do my little function command, and I can do L, right, and S, and I can run that, and then get like and subscribe. Pretty fancy. All right, let's move on. Okay, so I'm going to show you the scope and lifetime of a variable. So this is where we're going to talk about global and local. So we have like x equals 10, and we're going to make this global later. Okay, and then I'm going to have y equals 2. Okay, and as we know that this way when we use x and y, we can change the value anytime we want in our code. Okay, but I want to show you something. So let's define a function. And then what we're going to say is we're going to say y equals 5. And this is going to be local only to our function. Okay? So 5 is going to be local to that function. Okay? Then we're going to say we want global x. So we want x to be global. Now I can say x plus equals 1. So add 1 to my global. Okay? So now if I call the function, it's going to change my x. Okay? So I'm going to print x, and then I'm going to print y. Okay? So I want to show you something. Y equals 5 here, but that's only local in our function. Okay? Where we have x is 10 up here. So I can do function, and I'm going to print x, and since I'm defining it as global, x is going to equal 11 down here. What do you think y is going to equal? Is it going to equal 5? No, because that's only inside our function. We're referencing this y up here, and that's still a 2. So if I run this, I can do 11 and 2, just like we stated, because we are calling this y up here for the 2. The function, we're calling this 10, we're making it global, and we're adding a 1 to it, which we're making 11. So we can actually change the function and change the variable through the function that way by defining it global. Again, I don't like using global variables. I'd rather just call it and then define another variable to it. It just makes more sense to me to do it that way. How would you use it? I am kind of curious. So just to show you another example, we can do like x, right? And we can do plus equal. Instead of 1, we can do y here. Okay? Just to show you that that's going to be 10, and my y is 5, so that should give me 15 because I'm referencing the y in my local, not the y up here. So if I run that, I get 15 and 2 as expected. And, hopefully that kind of clears up that for you. So let's talk about higher order functions. And these are basically functions that take other functions and arguments, okay? So let's say that we have a function up here that we say, you know what, I want to shout, and I want to shout a text out, okay? And what I can do is I can return that text, okay, as upper. So make it all uppercase. And, I also have like dealing with strings. I do have a video on that in the lessons as well if you want to take a look at that. And, all these lessons I'll put in the links below for you guys. So the next one we want to do, let's say I want to whisper it. Okay, I want to be very quiet. Okay, so I could do whisper, and I want to do text dot upper, not dot upper, I'm sorry, text, and I'm going to put a space between these for I don't look at them. So I have the text, and I want to whisper. So what we're going to do for a whisper, we're just going to say, let's say it's all lowercase, right? So I can say text dot lower, okay, and then kind of call that back, right? And I don't know why I put the parentheses there. Okay, so we have the text lower, okay? So now what I want to do is I want to have a function that will be able to call those two functions. So I can do def and then greet and then say that I'm going to pass this to a function, okay? There we go. And then I'm going to return the function. And what am I going to pass with that? It's going to be, let's say, hit that notification bell. Okay? Pretty simple. So now to call this, what I'm going to do is I'm going to print, and then I'm going to greet, and I'm going to shout this, right? So what would I do? Just put shout in here. So I'm going to run my greet, say my functions hit that notification bell, and then I'm going to pass that on to shout, which is going to go up here, and it's going to return my text to upper. So if I run that, it's going to say hit that notification bell. That'd be great. Okay, now for the people who likes the whispers, right? I can whisper it to you, right? So I can put in whisper, and I can say, hit that notification bell. And there it is. Hit that notification bell in a whisper. Okay? So calling other functions is really as simple as that. Okay, so we're going to talk about closures and nested functions. Okay, so closures and nested function, they're members of values from in the closed scope. So how do we do that? Well, we'll have an outer function, and we'll call it outer, and then we'll pass in x. Okay, then we're going to have an inner function. We'll call it y. And what this inner function is going to do is I'm going to return x plus y. Okay? So I return that inner function. Well, I haven't returned anything for my outer function yet. So what do I need to return for that outer function? Well, I'm going to go back, and I'm going to return inner for my outer function. Okay? So that's going to be pretty straightforward, I think. I'm talking about the easiest way to kind of explain it. So let's say that I want to add 5, okay, and let's say that I want to say my outer is 5. So I'm going to add 5 to my outer. Okay, so outer is going to be 5. So now I got to sit there and call my inner. So now what I can do, I can print add 5 because I already have my outer calling as a 5, and I'm adding it, right there. So the value is add 5, and that's going to be up here in this x is in my outer is going to be 5. Okay? Then what I want to do is I want to make sure that I call that next variable in, which is going to be, let's say, 10. 10 is going to be my y value. So this add 5 is my x. This 10 is my y. So basically what's going to say, it's going to come up here. We're going to add 5 equals outer 5. It's going to go up here, the x, and say, oh, yep, outer x, that's going to be a 5. So now I'm going to print that outer, which is now add 5, and then I'm going to really add 10 to it. So if I go down here to the inner y, x plus y, it's 5 plus 10. And if I run this, I'll get 15 as expected. So that's basically like a simple of using the closure for the outer and the inner kind of nested together. If you have a better use case for that, let me know, because I'd love to hear it. Alright, so we're going to look at the recursion. And basically a recursion is a function that calls itself. The easiest way to show this is by using a factorial. And I do have videos on numbers that kind of goes over the factorial. You can take a look at that if you want. I'll have the link in the description. But for this one, we're going to do the factorial, and we're going to do 5, for example. Okay. And as we know, the factorial of a 5, we take 5 times 4 times 3 times 2 times 1, and that'll equal 120. So what we want to do is we want to turn the factorial number, which is 5, and we're going to multiply that by the factorial of n minus 1. So basically what's going to happen is we're going to kind of come down here and we'll do the factorial of n minus 1, and we're recalling that factorial So it's going to be a 4, then it'll be a 3, then it'll be a 2, then a 1, then a 0, and then a -1, a -2, and we don't want it to go back that far. We want it to stop at 0. So if we do if n equals 0, right, then what we're going to end up doing is we're going to return a 1. That way we'll get the correct answer, okay, because it's going to stop once that 0 returns a 1, and if you multiply 1 by 1, you're actually going to get 1. So now once we write that function out, we can do print factorial, and we'll do our 5, and we run this, and it says invalid syntax. So why is that? Did I misspell my factorial? I did. Alright, so I misspelled my factorial. So if I run it, and it still says invalid syntax. Oh, that's because I put 5 up here and I didn't put the n in. So what it is like when I do my factorial, this is a 5, it passes into this n, and then it kind of goes down in here. So I just had a typo up here. So if I run that, I'll get my 120. Okay, so doing a factorial is actually as simple as that. So I apologize for the typo. Alright, so let's talk about decorators. Decorators are functions that modify other functions' behavior. So basically, if I have a decorator, and then I'm going to make sure that that works with functions. Then I'm going to have a wrapper, and inside that wrapper we're going to do print, and this is before function call. Okay, and then I can call the function, then I can print after function call. Okay, so now that I have the print and function call, I can return the wrapper. Now I can do another function, and I'm just going to name this say it, and then I'm going to do print, and then it's going to say please subscribe. Okay, and then down here I'm going to say it. So I'm going to call say it, and if I run this, I have an unexpected, because I didn't put my open close parentheses there. Okay, so now it says please subscribe, and you're like, well, wait a minute, we didn't see this before the function call or after the function call from our decorator. We did not, because the way that this works is that I can use the at sign, and from the at I want to call the decorator. Okay, now if I run this, it says before function call please subscribe, after function call. So it reads the before function call right here. The function is down here with the say it, which is please subscribe, and then the after function call. So you can actually use those decorators and for that, and kind of wrap your functions and kind of use those on there. You can actually use those as middleware if you want to kind of sit there and say, I want to do this check before I give them access to this. You can use your wrappers that way as well. Alright, the last thing we're going to do is docstring and type hints, right? So just to kind of write a good function, what you're going to do is you're going to define your function. You're going to have a good name for your function. And then we'll do A, for example. And let's say that we want our A to be integer. So we're just going to make sure that our A is an integer by defining that. And then B, we want that to use an integer too. Okay? Now, these integers, right, I'm talking about we can make them strings if we want, but we're just going to keep them integers because we're doing an add, and adding we want integers. Now, what does the output look like, right? So I want the output to be an integer. Okay, so that way that when we look at this, we know that A is expecting integer, B is expecting an integer, and the output is supposed to be an integer. Okay? So the next thing we want to do is put in 3 quotes in here. And basically we want to say this is return the sum of 2 numbers, because that's what this function is going to do. Just for somebody who looks at your function will know exactly what it's supposed to do. Okay? Then we're going to return A plus B. Okay? And if I run that, I'm talking about that has our function. It's in memory. I could run it when I want to run it. Okay? So now what I want to do is I want to print, and then I want to do add my function, and I want to print my print the docstring. So I put the docstring in here, and I run this, and that says return the sum of 2 numbers. So that's pretty good. But if I really wanted to be a little bit more explicit on that, I could change my docstring and just kind of give it a nice little layout here where it tells me my parameters and then what it returns, and it returns the sum of A and B. And if I run that, and now if I print add.doc, it shows me exactly what that function does, like in the command. So if somebody don't know or doesn't want to look for it, they can just really quickly put this string in there, and it'll tell you exactly what that docstring says, kind of like a helper. Okay, so that's the docstring. Now, if I could sit there and actually go down here to this cell down here to show you this, I can print add annotations, and if I do that, it will show me that my A should be a class as an integer, B should be an integer, and the return should be an integer. So it kind of lays that out like in a dictionary that you can look and kind of use as a helper as well. Alright, so that basically covers the basic Python functions. If I miss anything, or if I need to explain something better, please leave it in the comments, because as a community we will get better. So what we went over is the type of functions. We went over the function parameters. We talked about the return values. We talked about the scope and lifetime of variables. We talked about the higher order functions, the closure and nested functions, the recursions, the decorators, and just writing good functions using docstrings and type hints. And I hope this has been helpful for you. And again, leave the comments below how it helped out or anything that we can improve on. And I'll catch you guys next time.